Right now we're going to try and find the value of some actual angles. So here are our two lines. How do we know that they're parallel? They've got that same arrow symbol there. And now we know the value of one of these, which is 115 degrees. That's our symbol for measuring angles. And then we have the angle here, A. Remember, angles are in lowercase. What degrees is A? Knowing what we know about the different types of angles created when a transversal crosses parallel lines, what do you think? Have a think what A is going to equal. So if we have two parallel lines and we have an angle on the inside of the two lines on alternate sides of the transversal, alternate, then we know that these angles are going to be equal. So we can say with great certainty that A equals 115 degrees. Easy. Now for B, do we have parallel lines? Because remember, if they're just random lines, we don't necessarily, they won't be equal. They won't work that way. But these lines are parallel because we can see those, these arrows. The transversal goes through here, and it tells us that the angle that we know is 55 degrees. Now who is A compared to that angle? A is on the same side of the transversal, but one is on the inside, 55, and then A is on the outside of the two lines. Well, that to me looks like they are corresponding angles. And guess what? More good news. Because they're corresponding, we can know right off the bat that A is actually equal to that angle indicated, and it's also 55 degrees, hashtag winning. And now, again, C. Remember, this only works, these rules only work if we run the transversal across two parallel lines. So we know they're parallel, check, that's the first point. Now, these two angles are on the transversal, but on the same side, so they're not alternate, so they're not corresponding, because corresponding one would be on the outside. So that means we must be talking about, and they're not vertically opposite, because this is vertically opposite, this is vertically opposite, and you can tell very much by looking at them that they are similar angles. But A is clearly much smaller, an acute angle. 110 is obviously bigger, an obtuse angle. So what's going on? Well, good news. These guys are co-interior angles. So what do we know about them? Co-interior angles will add up to 180 degrees. So how do I find the value for A? We will subtract 110 degrees and find that we have 70 degrees left. So our answer is A is equal to 70 degrees. Now, just finishing up this idea with example 3, giving reasons, state whether the two lines cut by the transversal are parallel. So, we don't see the two parallel lines. If there was a little arrow there, and then another one here, then we'd know they're parallel, but we need to find other means. So knowing what we know about the angles, what kind of angles are these? Think to yourself. They're inside the two lines. They're on alternate sides of the transversal. They must be alternate angles. But what do we know about parallel lines? Alternate angles are equal. Are these two numbers equal? They are not equal. So therefore, ergo, because the two numbers are not equal, and alternate angles when a transversal crosses parallel lines will be equal, therefore, these two lines are not parallel. Hallelujah. Now, bit trickier here, this one. We got two lines. We are not gifted with the little arrows that show us they're parallel, so we have to prove it. These two lines are on the inside of both lines, and they're on the same side of the transversal, so they're co-interiors. If they're parallel lines, these two will add up to 180. So, using our handy-dandy addition algorithm, 8 plus 2 is 10, 5, 6, 7, carry the 1. We have 180 degrees. Therefore, ergo, we've got parallel lines, everybody. Write home that one. There you go. There's the news of the day, and there's your homework.